about some problems with the telecommunication networks. Actually, when we are uh, in rest times or maybe enjoy your life, yeah. Imagine that you are watching your TV, your favorite TV program, yeah, maybe a soccer player, I don't know, or maybe are you watching online class, yeah, from your preferred university, and someone happened, yeah. What will happen? Maybe a ship in the middle of the ocean got the fiber optics when your data comes from the source to us. Yes, that's happening. Or sometimes. Okay? I want to talk about what is the problem with the telecommunication networks. Actually, our world is wired for the fiber optics around the world. And the idea is I have a source, I have an event, yes, and I have a lot of consumers around the world of the same signal, yes. That is the multicasting service. Yeah. Okay. The multicasting service always has only one source, or the most of the time we don't have multicasting service. We have the unicast service. The unicast service, we have a source and we have a destiny, yes? And the data comes or is delivered around the one path, in that case, around the point or the router A, yeah? But what happens when we have a cut in the path? The data needs to come around the other ground, around the other path. That needs time to find other path. That path is a dedicated path protection. Yeah? That is a kind of resilience. But here we need to get another or alternative path that because someone. Or graph alternative path, but sharing some links or sharing some points in the network. That is called shared path protection. Yeah? We have two kinds of resilience. The resilience is the property of the network that on which can delivers the signal or delivers package when face a problem or face a cut in the path. Okay? Our problem is the multicast service. We can choose the multicast service like a tree, yeah? When we have only one source and a determined number of consumers. Yes? And the service is delivered by a tree. Yes? That is the idea. Okay? What is the problem? The problem is what will happen with the consumer when I cut a link, when I eliminate an edge from that graph. Yes, that is the problem. Okay? Okay. What are we gonna do? We started to study that kind of networks. The idea is to choose a topology of network, yeah, and apply one or two the kinds of resilience showed before. We start with a network-ready topology, making some random connection between points and finding the trees into that graph. Or we can choose another topology that is power law. The power law is we send or we put a lot of vertices, and by the power law apply or connect 2 points in the network. And actually, recently we were studied that kind of topology. It's called HOT. It is a kind of hierarchical, yeah, organization, and that kind of network, so that kind of topology have shown will be more resilient against failures, against multiple failures. Okay? How we get, or how we construct or find new trees or new connection when we experiment failures. The idea is to make or to build genetic algorithm. The idea is to find a chromosome displayed or a chromosome representative in a matrix, matrix adjacency in graphs, and run some variation or some random variation of that graph to find a new protection, sharded flag, or dedicated path. After the running the simulation, we have to construct, or we have to develop that simulation, that simulator, get the time and calculate the complexity. The idea for this study is to demonstrate that our algorithm has lower complexity than the previous one, that is the idea. And they can show the results in less time. Okay, that's all. Question?
How do you measure the complexity?
How
How do you measure the complexity?
measure the complexity?
Measure.
Okay, the complexity of the complexity of the
Yeah,
algorithm.
complexity, like
The complexity of the network or the complexity of the algorithm?
I don't know, but I don't understand. No, but because in my field is complexity, and it's interesting to know how do you, what is for you complexity?
Okay, the complexity of the network is measured in the amount of vertices and the amount of links in the networks. Yeah? And the complexity in the algorithm is how many cycles you need or needs your computer for find a new answer or the best answers. Yes? That is two kinds of complexities.
Okay, I say that because when you speak about complexity in the general field, is a very specific word, and normally use an enthalpy measure
Okay.
to measure the complexity of the network.
Okay.
Use two concepts of complexity related with the size of the systems.
Yeah.
Different, but not complexity, size. It's more appropriate term. I believe that, right?
Are you using a dialectic algorithm for the solution of the problem? When you talk about the an evolution methodology?
Yes. Recently, I did a study on an algorithm proposed for the University of Kansas. Yeah. When they construct or they find new solution, thinking the nearest link that belongs to the path. Yeah. But I think that it could be developed better.
So it's a different algorithm.
Yes, take years to get a different algorithm.
So the complexity of the algorithm is since the genetic algorithm use probability to generate new individuals.
Yeah.
How to measure the complexity, since the complexity normally is associated with the steps, basic steps, and in the genetic algorithm it is not a clear concept. So it's explained as
I also will be happy when I hear that. Not answering.